In this video, we are going to explain FIR filter realization structure. One of the type, that is linear phase realization. Up to now, I have completed cascade form realization, direct form realization. Now, linear phase realization. Linear phase realization. So, okay, we know that the condition for the linear phase FIR filter, that is linear phase FIR filter should satisfy the condition. What is that? H of n should be equal to H of n minus 1 minus n. And we know that for an FIR filter, the transfer function is H of z is equal to summation n0 to n minus 1 H of n z power minus n. Now the case 1, n is even. So now H of z is equal to, if n is even, so just to decompose this one or split this summation into two terms. One is summation n0 to n by 2 minus 1. Then plus the second term is n by 2 to n minus 1. For example, if n is 8, n minus 1 is 7, n by 2 is 4, n by 2 minus 1 is 4 minus 1, 3. So that means here 0 to n minus 1, 7 samples are there. For the case n is equal to 8, 0 to 3, 4 to 7. So 0, 1, 2, 3. Here 4, 5, 6, 7. In this way, we just decompose our summation into the 2. So that's why here take the first one, summation limits are from 0 to half of the samples, means n by 2 minus 1. Then remaining samples from n by 2 to n minus 1. So now, so take the second summation. So concentrate on second summation. Here H of n is equal to H of n minus 1 minus n, property or condition is there. So in the second summation, place at n is equal to n minus 1 minus n. Therefore z power minus of n minus 1 minus n. Here n limits are, if you maybe if you may confuse by placing this n minus 1 minus n in terms of n. Just convert this one into the another variable, first m variable, like this one. So right, m, here is m, here also m. Now assign m is equal to n minus 1 minus n, right? Now here m variable range. So right, so in this way you can modify. Okay, right? If you have the clarity on this, no need to convert this one, right? So directly place n, and then you can find out the limits, right? It's okay. M is equal to n minus 1 minus n means here m is n by 2, right? M is n by 2. Then n limits are so n is equal to n by 2 minus n plus 1. N by 2 minus n means minus n by 2, then plus 1, that is minus n. Now what is n here? So see here, n minus 1, n is equal to n minus 1 minus n by 2, right? Now n by 2 minus 1. Okay, now m limits n by 2 minus 1. What is the upper limit here? Substitute in the place of m. What is that? N minus 1. Now what is n? 0, right? So now in this way you just convert the second summation, right? Now summation limits from n by 2 to n by 2 minus 1 to 0 means we may write from 0 to n by 2 minus 1. So now that is equal to h of z is equal to, what is the first sum? n0 to n by 2 minus 1 h of n z power minus n plus second sum 0 to n by 2 minus 1, and then here is h of n minus 1 minus n z power minus of n minus 1 minus n. And of course from the linear phase FIR filter we know that h of n minus 1 minus n is nothing but h of n. I am using that one, n by 2 minus 1. Here is h of n, z power minus of n minus 1. Here is z power n. So now continuation here. Okay, right? So now here don't split this one like this. Place same as it is, right? Z power n minus 1 minus n. Okay, right? Now so take the summation n by 2 minus 1 h of n. It's a common thing in the both terms, z power minus n plus z power minus of n minus 1 minus n. Okay, right? So now here this is nothing but h of z. So now here I am writing, this one is y of z by x of z. Now what is y of z from this? So substitute n 0 to n by 2 minus 1 values and then multiply each term with the x of z. Now see this, h of 0, z power 0 means 1, z power minus of n minus 1 into x of z. This is the first term. What is the second term? H of 1, z power minus 1, z power minus of n minus 2 into x of z plus h of 2, z power minus 2, z power minus of n minus 3 into x of z, and so on. H of n by 2 minus 1, then z power minus of n by 2 minus 1 plus z power minus of n minus 1 minus n by 2 minus 1 means n minus n by 2 means n by 2 minus 1, then there is minus of minus 1 plus 1. That's why here this is minus 1. So see here, n minus 1 minus n by 2, n by 2, here is a minus again, n minus 1 minus n by 2 minus 1 means here plus 1. What is this here? N by 2. Okay, right. So okay, this one is n by 2. Into x of z. Okay, right. So this is the equation. So now, realization structure for this equation we have to realize that the structure is said to be linear phase realization structure for n is here. What is that? N here even. Okay, right. So now see this. So realization structure, and then so here this formula, first what is that? H of 0 into 1 plus z power minus of n minus 1. That means we first sum the here delay units. So that means here is a delay unit. How many delay units? N minus 1 delay units are there. We have to add this one with the 1, and then here n minus 2 delay units with the 1. Here n minus 3 delay units with the 2 delay units. Here n by 2 delay units with the n by 2 minus 1 delay units. That means here, so see this structure, very interesting. That is, take here x of n. How many delay units are there? N minus 1. So here 1, 2, z power minus 1, z power minus 1, and so on. Here also z power minus 1, place here also z power minus 1, like this. Now here use z power minus 1. So in this way, smartly we just connect unit delays, right? So see this, right? Z inverse. Okay, so how many here? So this one is z power minus 1. Here you can get z power minus 2, and then here okay, so okay, here z power, consider like this, n by 2 minus 2. This one is z power n by 2 minus 1. Here this one z power minus n by 2, and then in this way this is nothing but z power n minus 1. Here is n minus 2. Okay, in this way, right? So consider like this. So now here we should add this z power minus of n minus 1 with the 1. Okay, so now see this, here we have z power minus of n minus 1. Just add this one to the, use a summer like this. Okay, like this. What is the resultant one here? Z power minus of n minus 1. Of course here x of z also there, x of z, then here is the x of z. If you common x of z, 1 plus z power minus of n minus 1. Okay, now here that is multiplied with the, that is multiplied with the h of 0. H of 0, right? So now, then what is the second term here? Z power minus 1 plus z power minus of n minus 2. So see this. If it is z power minus of n minus 1, last one, n minus 1 delay units are used. Obviously it is nothing but z power minus of n minus 2, right? So now, so do the sum here. Now multiply this one with the coefficient h of 1 in the similar way, right? Here also z power minus 2 plus z power minus of n minus 3 multiplied by h of 2. Now here also right, so here also, right, now here also. Okay, so now this is nothing but h of, what is the value here? Observe. So what is this? This is nothing but here h of n by 2 minus 1, n by 2 here, see, 1 minute, here previous term is nothing but h of n by 2 minus 2, right, h of n by 2 minus 2. Okay, similar way here also use the multiplier, right? What is that here? Z power minus of n by 2 minus 2, the previous term, for this previous term. It's okay, right? So this one, and now here add all these multipliers. This is n by 2 minus 1. It's okay. Now add all this. So here plus here is a y of n. See this? So connections, path in this way. Okay, see. So in this way you can get the y of z. Okay. So h of 0 into 1 plus z power minus of n minus 1 x of z. Next one plus h of 1 into z power minus 1 plus z power minus of n minus 2 and so on. So okay, like this. So we can realize the any FIR system, but that FIR system should satisfy the linear phase condition. Okay, so in this way you can reduce the number of components, number of units here. Okay, right? Now coming to the next case, that is case 2, that is n is odd. In this case, h of z is equal to, what is that h of z? Summation n0 to n minus 3 by 2, first half, right? So n is odd means n minus 1 means even samples are there. That means here, see this, n0, n plus 1 by 2 to n minus 1 plus middle term, this one. So that is like this. Okay, see here in this previous example. So here n is even. N is even means n minus 1 means odd. So right, so odd means here 0 to 7 samples are there. 0 to 7 samples are there. So first half means 0, 1, 2, 3. Next one 4, 5, 6, 7. Right? In this way you just split the samples into equally 2 parts. Right? But now here consider this. N is odd. N is odd means like, so for example 7. So 0 to 6. That means 0, 1, 2, 3, 4, 5, 6 are there. But here we should split this one into, right, 2 equal parts, like 0, 1, 2, 4, 5, 6, but 3 is the middle one. So it is a single one. So that means to separate these samples, right? So in a 3 terms, the first half, last half, middle one. Okay, that's why here it is represented as, middle one is represented as n minus 1 by 2. 7 minus 1 means 6, by 2 means 3. See this. This is nothing but n minus 3 by 2. That means 7 minus 3 by 2. What is that? 4 by 2 means 2. Right? So in such a way, 4 means n plus 1 by 2. That means 7 plus 1, 8 by 2 means 4. In such a way, right? So for n is odd, so now here to split this particular h of z equation, use here 3 terms. First half and then last half, and then here is a middle one. Okay, so middle one is here h of n minus 1 by 2 z power minus of n minus 1 by 2. So okay, now here also as in the previous case, so apply the linear phase FIR filter property. So here is a first term, I am writing the middle term here like this. Now n0 to n minus 3 by 2 h of n z power minus n plus the second term is n. Here I am using in the place of n capital N minus 1 minus n, z power minus of n minus 1 minus n. Okay, here so n limits are n plus 1 by 2 to n minus 1 means it becomes n minus 3 by 2 to 0. So now it is nothing but 0 to n minus 3 by 2. Then here this is equal to h of n minus 1 by 2 z power minus of n minus 1 by 2 plus summation n0 to n minus 3 by 2 h of n, since this one also equal to h of n, common this h of n, then z power minus n plus z power minus of n minus 1 minus n. This is nothing but h of z in this case. So now consider here, that means expansion. So expand the series as in the previous case, right? So that is nothing but h of z is equal to h of z is equal to y of z by x of z, and then so find out the y of z. What is the y of z here? The term is the first term. What is that? H of n minus 1 by 2 z power minus of n minus 1 by 2 into x of z plus. So for n 0, small n 0, this is nothing but h of 0 1 plus z power of minus n minus 1 into x of z plus h of 1 into 1 plus z power minus 1 plus z power minus of n minus 1 minus 1 means n minus 2 x of z. H of 2 is not h of 2 into z power minus 2 plus z power minus of n minus 3 and so on. H of last term is n minus 3 by 2 z power minus of n minus 3 by 2 plus z power minus of n minus 1 minus n minus 3 by 2. What is this? 2n minus 2 minus n plus 3 by 2. N plus 1 by 2. Z power minus of n plus 1 by 2. Right? Okay, in this way, just write the equation first and then observe. So here first place as the previous case. So how we smartly group the delay units. So same in the same way here also group the what is that? Delay units. So okay, see this here, x of n, first place the delay units. How many delay units are there here? Right? So same thing, n minus 1 actually, but here n is here odd, right? So in this case n odd means n minus 1 means even values. That's why here even number of delay units means here don't include any z inverse as in the previous case. We included separately one delay unit in this case, right? So and then we included all z inverse, that means unit delay units equally, right? So here first row, second row equally, but we have included one delay unit in the previous case, but here don't include this one. So that means here n odd means even number of delay units are required. So that's why, remember that's only the difference here. So now here same thing, same structure. You just take the summer. Now here use the multiplier. Here also. Here also. Okay, then here add one multiplier, that is here middle one, this one. Okay, now add all these resultant ones like this. This is y of n. Here is h of 0. Here h of 1. Here h of 2. Here h of 3. And so on. Here h of n minus 3 by 2. Here h of n minus 1 by 2. In this way. Okay. So here place the directions like this. Here also. Don't forget to put these arrowheads here, very important. It's okay for n naught. This is nothing but linear phase realization FIR system. For FIR system, here the number of multipliers required are here in this case n plus 1 by 2 number of multipliers. Okay, in the previous case that is n by 2. In the previous case number of multipliers n by 2. Okay, right? Thank you.